Hey everybody, it's Monty, and here we are thinking about the last week of the school year. Are you kidding? So, week 37th, and we're on our Monday, Tuesday, June 14th and 15th, and we are really hoping that we're finishing the year off with the topic that excites you, okay? Math doesn't have to be boring. Math can be about dice, cards, games, probability, and the chances of stuff happening. How do we describe the world? This is like the introduction to statistics. And if you ever read the paper, if you're looking to go off to college, we in America are very interested in predicting things, okay? Making educated guesses about what could happen. And to predict the future, we have to study what is happening. Okay? We want to look at an election. How many people do we need to poll to make a good prediction? If we have 100 people, is 10 enough? Does that give us a good indicator? Okay, so back to the fun part. What are the chances of stuff happening? All right, so this week we're going to go the next step, independent, dependent. We looked at that last week. Now, given statements, knowing that this happened, what is the chance of this happening? Okay, and those are called permutations. The more times we do it, does it come out the way we think it's going to come out? All right. Cheat sheet. Let's make sure we look at the entry task for the deck of cards. Huh? What? Now, I love this stuff. At the same time, I am aware that there's a lot of words and that it tends to be confusing the first time you read it. Okay? So, consider the 7 days of a week. Consider the 7 days of a week. Suppose the name of each day is written on a separate sheet of folded paper. You place it in a bag. You reach in the bag and choose one of the pieces of paper. Really? Determine the probability randomly choosing a day that starts with the letter S. Go. Okay? Hopefully, you have time in class to do this. Randomly choosing a weekday, randomly choosing a Wednesday. Have this discussion, okay? This could take 10 minutes, all right? So, enjoy it, embrace it, and get your gears turning toward probability and chances. All right, look at all these vocab words. Holy Toledo. The outcomes, the sample space, the event, the probability, okay? There is a lot of words, a lot of vocabulary to something that you already are pretty good at. All right, so hopefully you had a discussion. Hopefully you talked about the weekdays. Okay, picture yourself reaching in and pulling out, and let's get started. All right. Okay, you got your cheat sheet, and we've done the fundamental counting principle. We talked about independent events. We talked a little bit about dependent events. This is where we're living this week, right here. Wow, look at that math formula. What the heck is all that? Okay, compound probability, right? If we roll the green die and the yellow die, the chances together. Order of things. This idea of factorial. Now, you may not have talked about the actual word factorial, but you did some of this, right? 3 times 2 times 1, okay? All right. The card problem, okay? Now, depending on which cohort you're in, you may have done this problem, you may not have done this problem. Okay, this is our Friday activity, okay? Last Friday and the last Friday. So, in this activity, a deck of cards has 52 different cards. 4 suits, okay? If you're not used to playing cards, that's okay. Here they are. Why is my head always in the way? 4 suits, clubs, hearts, spades, diamonds. Each suit has 13 cards, 1 through 10, 11, 12, 13. What's the probability of drawing a king? Now, depending on which cohort you're in, you may have done it, you may not have done it. I'll ring the bell. That means pause the video, have a discussion, okay? Make sure you're all on the same page, because not all of us have the same skill level with decks of cards. All right? So, pause the video, work through these three problems, okay? All right, welcome back. Now, what is the probability of drawing a king? All right, now the reason we handed out the big cheat sheet packet is because I want you to draw these. I want you to actually experience probability, okay? And it's more fun if you got some colors and highlighters to work through this, okay? Well, what is the probability of drawing a king? Okay, I'm just going to find my highlighter here, and I like to use green. King, there's 4 of them, okay? The first thing you want to do, always think about partial credit. Everybody doesn't realize how important partial credit is. The reason I push partial credit is because you have to have a starting place. You are entitled to get points for your thinking. I see 4 kings. Absolutely. These are the winners. Now, out of how many cards? 52. That's a perfect answer. Okay? My head is in the way again. Okay. Now, proper math. Teacher gets involved. 4 out of 52. That's a great answer. Keep pushing yourself on simplifying fractions. 4 times 1, 4 times 13. Now, I know not all of you knew that, but some of us do this for a living. 4 over 4, 1 over 13. Get used to using your fancy calculator, because the TI does this for you. It can help you with these type of problems. 4/52, math, convert to a fraction, enter, enter, 1 over 13. Okay? All right. So that's a better answer. What is the probability of drawing a heart? Okay? Again, we're going to go up here. We'll grab a different color highlighter. Grab blue. Well, partial credit. How many hearts are there? Okay, grab a different color here. 13 hearts. Okay, out of 52. Okay, so 13 over 52. Again, 1 out of every 4. Yep, 13 times 1, 13 times 4. 13's cancel. 1 out of every 4 cards is a heart. Alright, so either of those answers, we're happy. Now comes the compound event. Okay, now comes the idea of a given statement. Alright, what is the probability of drawing a king and a queen on the first 2 cards drawn? Now, hopefully you had a discussion. Lots of different ways to think about it. Here's the teacher way. King and a queen. King and a queen. I'm going to grab a different color highlighter. I'm going to grab a narrow purple. First card drawn can be a king or a queen. First card drawn can be a king or a queen. How many kings and queens are there total? Now, 8 total kings and queens out of 52. So, on the first draw, 8 of 52. Now, here's the key to this week, right here. Okay? Here's the key to this week, the last week of school. The second draw. What's the probability? Okay? You just drew a king or a queen. It's gone. On the second draw, how many kings and queens are left? There's 7 total kings and queens. Okay? Out of, one card is gone. How many? 51. Nice. Alright, so 7 of 51. So the second draw is 7 of 51. Now, the probability of getting a king, queen, first 2 cards is 8 out of 52 times 7 out of 51. Okay, now here's the learning. Okay, just like the dice, total number of chances, 1 out of 6, 1 out of 6, 1 out of 36. All the possibilities. There's 56 different ways to get a king and a queen. Okay? This one, this one, this one, this one, this one, this one, back and forth, back and forth. Okay. But look at this number. Massive. 52 times 51. 2652. Very popular number in decks of cards. 2652. Is that what it said? 52 times 51. Sorry. Alright, 2652. That's the total number of possible ways to get a king and a queen on the first 2 cards. Out of 2,652 different ways to draw these cards on the first 2 cards. Okay? Now, I would just leave it like that, but let's do the math. Let's go 56 divided by the 2652, and we get some crazy number. Math, convert to a fraction, enter. 14 of 663. Okay? Alright. There's 14 ways out of 663 to get that answer. Alright. Now, the last one. 3 of a kind. Now, first 3 cards. Okay? Just draw. 1, 2, 3. Okay? What is the probability of getting 3 of a kind? Pick any 3 of a kind. Okay? Have a little class discussion on this one. And we'll just pick lucky number, what, 7? Cool. Now, how many 7s are there for winners of the 52? Now, I drew it. Boom. How many 7s are left on the second? Let's see, the first draw. The second draw. Okay, I got a 7. Second draw. How many 7s are there? 3 winners of 51. Then there's 2 possible 7s out of 50. And this is the key to the donut problem on the back wall. Each day, each time a donut is drawn, the bottom number changes because there's less and less and less. On the top, less, less, less. But just like the die, okay, probability. The reason these are more difficult is because we have given statements. Given we drew a winner. How many possible winners are left? How many possible cards are left? But all of them are multiplication. So now our final 4 times 3 times 2 is 24. And 52 times 51 times 50, I have no idea. 52 times 51 times 50. 132,600 different possible ways to draw the first 3 cards. Wow! Okay, so that's why drawing 3 of a kind on the first draw is crazy hard. Math, convert to a fraction. 1, it'll happen 1 time every 5,525 times. Okay? Alright, now you can see we're 15 minutes into class. We haven't started any of the work. This is the fun of math. Have a discussion. Enjoy your decks of cards. Try it with your neighbors. Shuffle the cards. Shuffle, 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 shuffle. Draw 3 cards. Boom, boom, boom. Did you get 3 of a kind? What are the odds? What are the probability of drawing 3 of a kind? 1 out of 5,000 times. It's not going to happen very often. Alright? So I'm going to just end this video, and then I'll come back, and the rest of today and Wednesday, Thursday, we're just going to be talking about decks of cards, different scenarios, and how we think about dependent events given a particular circumstance that just happened. Okay? If this happened, what's the probability of this happening? Enjoy the last week of school. Let's throw them bones. Let's play some cards. And let's finish the year off excited about the world of math. See you in a minute.